Chapter 12, Number 54. Suppose a planet is discovered orbiting a distant star. If the mass of the planet is 10 times the mass of the Earth, and its radius is 1/10 of Earth's radius, how does the escape speed of this planet compare to that of the Earth? First of all, it's going to be much larger because the mass is bigger, and it's also, you're much closer to the center. So it's going to be vastly bigger. So let's draw a picture. The basic idea with escape velocity is that we want to go from the surface of the planet to quote-unquote infinity, and we want to reach infinity quote-unquote at rest. In other words, always slowing down but never quite stopping. And so we want to say we're going to balance our energy. The energy at launch is the energy at the end. The energy at launch would of course be 1/2 the mass of the spaceship times the velocity it has, its escape velocity squared, and its initial potential energy, which is g mass of the planet, mass of the spaceship over the radius of the planet, with no square. Let's call these MP and RP. And then we want this to be that we reach infinity at rest. And since we're at infinity, we have zero potential energy by construction. So our total energy is 0, which is kind of weird, but we're just saying we always trade off kinetic energy to potential energy, and they happen to add up to 0 in the escape condition. That allows us to solve for the escape velocity. Not surprisingly, the mass of the rocket drops out, and we end up with the velocity escape squared is going to be 2g mass of the planet over the radius of the planet. And then I guess we can take the square root of both sides, and we have square root of 2g mass of the planet over the radius of the planet. But we know that the mass of the planet is 10 Earth masses, and the mass of, or the radius of the planet is 1/10 the radius of the Earth. So we can combine all that stuff and we can say, okay, well, then we have the square root of 10 over 1/10, and then the square root of 2g mass of the Earth over radius of the Earth. The first is just a thing we can compute. That's the square root of 100. And the second thing we have there is the escape velocity on Earth. So all told, we find out that we get 10 times the Earth's escape velocity on this other planet.